Okay, this lesson is on trying to determine how you draw a Borg diagram and a Lewis structure. You have to always begin with your periodic table. When you're given an element symbol, you have to go to the periodic table and decide where this particular element is located. The element that we're going to look at today is going to be Si, and this particular element is a nonmetal, and it is located in the 1, 2, 3 in the third period. Periods equal shells. So if I say it's in the third period, that means that I know that it's going to have 3 shells. Also, periods are horizontal. They go straight across, just like the days of the week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. That's the way that periods are designed in a periodic table. It goes across. Groups, on the other hand, are vertical. They go up and down. Groups are vertical. Groups equals valence electrons. Now, the particular element we're looking at today is Si. Si is in the main group, which is in group 1, 2, 3, 4. It's in group 4. So that tells me that Si is in the 4th group, and it's going to have 4 valence electrons. Everything in this group will have the same number of valence electrons. Okay? All right, now this is how we draw your Borg diagram. The Borg diagram consists of shells. You start out with a nucleus in the center, because that nucleus is filled with subatomic particles. And those subatomic particles are electrons, neutrons, and protons. And then we draw shells around it. So if we know that it's in the third period, it has 3 shells. We're going to draw 3 shells. 1, 2, 3. Now we also know that it's in the 4th group because it's a main metal, and I'm going to count over, and I'm going to skip metals 3 through 12 because those are transitional metals. I'm only looking at main metals, which is going to be your halogen family at the top. I'm going to look at your barium family. I'm going to look at boron, carbon, nitrogen, oxygen, and fluorine and neon. I'm going to look at those top of the families because that would comprise your 8 group. There are only 8 groups in the main family, and there are only 8 in the main metals. 8 groups in the main metal. Metals 3 through 12, we're not using those because those are transitional metals. Now that I have my shells drawn, now I have to figure out where my valence electrons are. Valence electrons are always in the outermost shell. Whatever your last shell is, that's your outermost shell. So this particular shell right here is your outermost shell. And that's where your valence electrons will go, only valence electrons. And here, because groups equals valence electrons, I can go counterclockwise and put 4 valence electrons there. I'm going to start here. 1, 2, 3, 4. Something I didn't put down is the atomic number. The atomic number for this particular element is what? 14. It's 14. So I know that when I finish, I have to have 14 electrons on this particular atom. On this particular element of this atom, it has to have 14. So the next thing you have to do is the first shell that's here, the maximum amount that it will hold is 2. It can hold 1, but it can't hold any more than 2. Okay? You can have 1, like you have small way. Hydrogen. Hydrogen only has 1. Okay? In this case, I will put my 1, 2 there. All right? So right now, I have given a home for 4 and 2. So my atomic number is 14. That means that my atomic number is the same thing, as your protons, okay, and your electrons, okay? So my atomic number is 14. I've used up 4, 5, 6. So I have, what's left from that? If I take away 6, which is 1, 2, 3, 4, plus the 2 that I've used in there. No. 1, 2, 3, 4, 5, 6. I've used 6. Okay, I use 4 valence electrons because I know that I'm in the 4th group. I have 4 valence electrons. Everything in this 4th group has 4 valence electrons. Everything. Okay, so now I've used up 6. Now I've got to find a home for the rest of the 8. Now I have 1 shell that I have put nothing on. Am I looking at this right? How many did I say? 3? Yes. I have 1 shell that I have nothing on. So now I have to put 8 valent. I have to put 8 electrons on here, and I go counterclockwise. If I start there, 2, 3. Where am I doing? Where's the ladder? Now, when I finish, I should have a total of 14 total electrons, whether they're valence or regular electrons. Okay, and this is the board. It only uses all of the electrons. Now, if I were to count them, I had 1, 2, 3, 4 out here, 5, 6, and I should have had 8 in here. 1, 2, 3, 4, 5, 6, 7, 8. And it's a total of 14. Always has to come back to this 14. Now, the Lewis structure.
So SI is this dot in the middle.
No. Well, see, that would be your symbol. SI is a symbol. SI is a symbol of your element, and your element is called silicon. Okay, the name is silicon. Right? So again, the Borg diagram uses all of the electrons. It uses all of them, and you have to know what your atomic number is. You have to know what periods it's in, because periods equal number of shells. You have to know what group it's in, because group equals valence electrons. So if it's in 4th group, everything in there will have 4 valence electrons. Everything. Do you have any questions? And you're going to have 3 of these. Now, with each element, like this element here, you're going to have to draw a Lewis structure. With a Lewis structure, you only have SI, and the Lewis structure only uses valence electrons, and we go counterclockwise around the element symbol. So how many would I have around this symbol? There are 4 valence electrons. So if it's in the 4th group, 4. Okay, I would need 4. Counterclockwise goes this way. And that will be your Lewis structure. And I would expect to see a Borg diagram, which is this one, and a Lewis structure, which would be this one for the test purposes. Were you in the lab the day that we had the periodic table, that all I had on there were, I had the 8 groups, and then each one had a symbol in the little box, and all you had to do was to draw, put the dots around it, the valence electrons?